This question is so beautifully designed that it will make you fall in love with math for real. We are given this equation, and we have to solve for x. I know that just by looking at it, most of us will quickly think of expanding the expression without a second thought. And that's not bad. But this is what separates a true math genius from the rest. The ability to pause, observe, and spot the hidden pattern or shortcut that simplifies everything. Because after expanding this expression, we will get this quadratic expression which becomes insanely difficult to solve. So expanding it might not be the most helpful approach here. By the way, take a moment to look at this quadratic expression. What do you think? How many values of x do you expect we'll get? Since we have a quadratic expression which means degree here is 4, it's natural to assume we'll get 4 values for x. Or do we? Let's find that out. All these numbers are in an arithmetic sequence with a common difference of 2. So what if I try to find the middle part of these numbers, kind of mean or an average of these numbers? So we get 3 plus 5 plus 7 plus 9 over 4 or 24 over 4, which equals 6. Whoa! I think we are getting somewhere. Let me substitute a variable y as x plus 6. So, what will be the value of x plus 3? Yes, right. Subtract 3 from both sides, and we get x plus 3 equals y minus 3. Oh, can you now see where we are heading? X plus 5 will become y minus 1. Then x plus 7 will become y plus 1, and x plus 9 will become y plus 3. We did all of this manipulation just to avoid expanding this big expression, and let us see if we can become successful in it. Substitute these values here to get this equals 9. Now look at these two expressions, and also look at these two expressions together. Do they look familiar? Yes. Both of them grouped together will be of the form a minus b times a plus b, which equals a squared minus b squared. So this becomes y squared minus 3 squared, and this will become y squared minus 1 squared. So now we have y squared minus 9 times. Y squared minus 1 equals 9. Nice! Now what? Are you again thinking of expanding this? Hold on, we can again reduce it into a nicer form. What will be the average of 9 and 1? It will be 9 plus 1 over 2 or 10 over 2, which is 5, right? So let y squared equals r plus 5. Therefore, y squared minus 9 will be r plus 5 minus 9, or r minus 4, and y squared minus 1 equals r plus 5 minus 1, or r plus 4. Thus, this is again of the form a minus b times a plus b, and thus this will become r squared minus 4 squared, or r squared minus 16, which equals 9. Thus, r squared equals 16 plus 9, or 25, and therefore r equals plus or minus 5. So when r equals 5, we get y squared equals 5 plus 5, or 10, and thus y equals plus or minus square root of 10. Now, when r equals minus 5, we get y squared equals 5 minus 5, or 0, and thus y equals 0. Now y equals 0 gives x equals 0, minus 6, or minus 6, and y equals plus or minus square root of 10 gives x equals minus 6, plus or minus square root of 10, and that's it. So, in the end, we don't actually get 4 solutions like we might expect from a quadratic equation, we get just 3. This just shows how a little creativity can turn a seemingly complex equation into something surprisingly elegant. As always, if you enjoyed this video, please don't forget to like, share, and subscribe to our channel. So good!